we're going to go over how to algebraically find domain and range of different radical functions. So for any radical function, our parent function for this is f of x equals the square root of x, or y equals the square root of x. We also have a graph of our parent function here, and for radicals, they all have a starting point, so I am going to draw that in, and there should be an arrow on the end. So if I look at this graph, I can figure out my domain because I can see that my x's include 0, and then it goes off into positive infinity. So there's a couple ways I can write this. I can say x is greater than or equal to 0, which would be more than sufficient, or I could say from 0 to infinity for my domain. Both work, both mean the same thing. But this notation is going to help us in this context. So what this means is that whenever we're given a radical, we want to take whatever is underneath the square root and set it greater than or equal to 0. And when we do that, our function will be defined and our domain will be set. Once we have our domain, we can figure out our range. I'm going to add a little note down here. By plugging in that value from our domain into our original equation. We also have graphing calculators, so we can double check the picture on the graph if we are allowed to use our graphing calculator. So I'm going to do this first one here. It says determine the domain and range of y equals the square root of 2x minus 19. So I'm going to start by finding my domain. So I'm going to take everything that's underneath my square root, so my 2x minus 19, and set that greater than or equal to 0. I want to solve for x, so I can add 19 onto both sides, and I get 2x is greater than or equal to 19. Divide by 2, I get x is greater than or equal to 9.5. So I'm going to end up putting my answer over here. So my domain is x is greater than or equal to 9.5. I still need to find my range. So to find my range, I want to take, let me grab a different color here. I want to take this number and I'm going to plug it back into my equation. So I have y equals 2, but I'm plugging in that 9.5. And all of this is under my square root symbol. So I end up with y equals 0, which might make a lot of sense that you don't have to do that work if we don't see anything added or subtracted on the outside. Because if we also think back to transformations, this minus 19 is shifting it to the right. I'm sorry. It's shifting it to the right because it's under the radical. If there's anything on the outside of the radical, it would shift it up or down. So it makes sense that my y value is 0 when my x value is 9.5 because that is my dot on my x-axis. I didn't shift it up or down at all. And so for my range, because there's not a negative on the outside, I know it did not get reflected. So it has to be going up and increasing. So I can say my range is y is greater than or equal to 0. And then I just kind of want to double check that. So I'm going to grab my graphing calculator. And what I'm going to do is type in my equation into my y equals. So I hit y equals, and I'm going to do my square root of 2x minus 19. I'm going to graph that out. And you'll see it's kind of right here. So I just want to make my window a little bit further. So let's take my x to 15. And so it's a little hard to see, but it should be on my x-axis and it's going up and out to the right. So it makes sense that x is greater than or equal to 9.5 because it's going to the right. And my range is y is greater than or equal to 0 because it's still going to be continuing to go up. So we're going to look at the second one here. For the second one, I notice we have a quadratic underneath the radical, which is going to make it a little bit difficult. So for my domain, again, I'm going to take whatever is underneath my radical symbol and set it greater than or equal to 0. I want to factor this. So whatever multiplies to -6 that adds up to +1 would give me +3 and -2. So I can break those down into x plus 3 and x minus 2. This is where I do want to check my calculator. So I want to check my graph. Because if I have two x's, I'm going to have like two curves in my graph. And I can either have them going apart like this, or they might be coming together and kind of connecting. So I don't know which one it is, which is important for my domain. So I'm going to put this in my graphing calculator. I have x squared plus x minus 6. So I just typed it in. I'm going to hit graph. And I see two separate pieces. And I'll also notice that this one is at an x value of -3, and this one is at an x value of 2, which makes sense because if I set each of these equal to 0, I get my -3 and my 2. And so now I can, I'm going to leave this here, I can visually see for my domain that I have x values are less than or equal to -3. Or they could be in this second curve here, and x is greater than or equal to 2. I need to include both of those for my domain. For my range, I can plug in, I'm going to circle this because that's what it ended up looking like. I'm going to plug in one of those numbers. Well, if I plug 2 into here for both of my x's, I should get a y value of 0 because I'm using the same logic that nothing is being added or subtracted on the outside of my radical, so it's not changing vertically up or down. So I have y equals the square root of 2 squared plus 2 minus 6. Well, 4 plus 2 is 6, minus 6 is 0, so y equals 0. And then I can also see on my graph that it is going up. So my range is y is greater than or equal to 0. So the last one, I want you to pause the video and try it on your own, and then when you're ready, you can start the video again. All right, so we're going to find our domain. I'm only taking the piece that's under the radical, so the 2x plus 20 is greater than or equal to 0. I do not care about that -4 right now, because the only thing that's changing the domain, that's moving it left or right, is what's under the radical. So when I solve this, I get x is greater than or equal to -10. And I found my domain. So over here, I'm just going to write that down so I can remember that. So that's part of our answer. Let me scoot this, I'm so sorry. And then for my range, I want to take that -10 and plug it in for my x in my equation. So I have y equals -4 plus the square root of 2 times that -10 is going in place of my variable, and then plus 20. So I have y equals -4 plus the square root of, well, this is -20, plus 20 is 0, so the square root of 0. Well, the square root of 0 is 0, So I get y equals -4. So as of right now, I can visualize what's happening even before I type it into my graphing calculator. If I have a coordinate plane, I know that my dot for my radical is at -10 comma -4. So -10, -4, this is not drawn to scale. So that's that point. Since my x values for my domain have to be greater than -10, I know it's going to be going to the right. And then here, I don't have a negative in front of my radical, so it did not get reflected. So it is going to be going up and over. So my range should be y is greater than or equal to -4. Now, I'm not quite sure, where it crossed here because that was just like a quick sketch. But let's put it in our graphing calculator and see what happens. So I have -4 plus the square root of 2x plus 20. I'm going to graph it. And I just want to change my window a little bit because it's a little too close on this side. I want to see what the starting point is. So I'm going to hit window, and I'm going to change my x min to -15. I'm just going to push that window a little bit further to the left. Actually, my graph was pretty good. So my starting point is here, and I can see that it's going to the right. So x is greater than or equal to that x value. And for my range, it's going up, so it is greater than or equal to that y value, which should be that -4. So I can see my range is y is greater than or equal to -4. So you can always double check it in your calculator if you have access to it. If you don't have your calculator, we can do it by hand for our domain and range. I hope that helps.